this section deals with e and the derivative of e as well as the integral of e. So you'll notice on your derivatives and integral sheet, if your format is e to the u, and remember e is a number and u is where your variable is, then its derivative is e to the u du. Or in other words, you write what's sitting there multiplied by the derivative of your exponent. Okay, so that's the derivative. When you're integrating, as long as you have the derivative of your exponent, then the integral is just e to the u plus c. Okay, so we're going to do a series of both in this section. And combine it, of course, with product rule and all that kind of good stuff. So for number one, we have find the derivative of the function. And our, what am I trying to say? Our function is x times e to the 9x. And I want to take that thing's derivative. So the bigger picture is I've got variables times variables. So I know I'm going to have to do product rule. So product rule says I write the first, which is x, times the derivative of the second. So the derivative, and the way I say this is I'm literally saying e to the, okay? So the derivative of an e to the is you write what's sitting there times the derivative of your exponent. Okay, so first times the derivative of the second means I write what's sitting there times the derivative of my exponent. And the derivative of 9x is 9. Okay, so first times derivative of the second plus the second, which is e to the 9x, times the derivative of the first, which is 1. And that's it. You're done. So one of the issues that people run into, don't use power rule on this. In other words, don't make this e to the 10x over 10. That's not how you do that because your variable is up in the exponent where you can't reach it. So we handle it a different way than what we do when the variable's in the base. All right, so for number two, we have y equals, and then I've got an x squared times e to the x, and we have a minus 2x e to the x, and then we have a plus 7 e to the x. Okay, so you'll notice that there's an e to the x in all three terms, so if you wanted to factor that out and then do product rule, you can. Otherwise, you can leave it as it stands. We'll have to do product rule here and product rule here, but not here. Either way, you'll get the same answer. It'll just look different. So I'm just going to leave it this way. So on the first set, I've got variables times variables. So how do I take this derivative? First, which is x squared, times the derivative of the second. So the derivative of an e to the is I write what's sitting there times the derivative of the exponent, which is 1. So I've got first times the derivative of the second plus the second times the derivative of the first, which is a 2x. Okay? And now move on. I've got this one times this one. So remember, this negative belongs to everything you do. Okay? So first times the derivative of the second. So a derivative of an e to the is right what's sitting there times the derivative of your exponent, which is 1. So first times derivative of the second plus the second times the derivative of the first, which is 2. And now I'm done with that negative, so stop here. Okay? So first times derivative of the second plus the second times derivative of the first, minus first times derivative of the second plus the second times the derivative of the first. So now I'm on the last one. So 7 is coming along as a constant multiple, and the derivative of an e to the is right what's sitting there times the derivative of your exponent. So that just goes to 1. So you're done. That's it. If you want to distribute this negative to get rid of those parentheses, you can. All right, so third one, I have g of t equals, and the way it's written is e to the negative 4 over t to the 5th. And I'm going to rewrite that, okay? So I'm going to rewrite this as an e raised to the negative 4 times t to the negative 5, okay? So this is a single term, and I'm just taking the derivative of an e to the. So what is the derivative of an e to the? I write what's sitting there, which is negative 4 t to the negative 5, times the derivative of my exponent. So this thing's derivative, drop your negative 5 out front to get a 20 times t to the negative 6. So I'll have a 20 t to the negative 6. And you're done. Don't do product rule. Don't do anything like that because you've just got a single term sitting here. All right, so for number 4, this says y equals the natural log of 9 plus e to the x over 9 minus e to the x. So now we're combining some stuff that you have just learned. I am in log world. So I'm going to go ahead and separate this out using 2 sets of parentheses. So if it's division on the inside, it's subtraction on the outside. So this is now going to become y equals the natural log of 9 plus e to the x minus the natural log of 9 minus e to the x. Okay? And now I can take a derivative. So how do I take the derivative of a natural log? I take the derivative of the argument. So what's the derivative of 9 plus e to the x? The derivative of 9 is 0. And the derivative of e to the x is just e to the x. So e to the x over the argument itself. Okay? Minus. Well, take this thing's derivative. So the derivative of 9 minus e to the x is going to be minus, because this goes to 0, so this negative is coming along for the ride. Because the negative is coming along for the ride, that changes to a plus. And then the derivative of e to the x is e to the x over the argument itself. And you're done. Nothing else. Okay? So number 5, we have y equals 4 over e to the x plus e to the negative x. Okay, so the issue here is I could bring this up top with the negative exponent and go from there and just use power rule, or I can use quotient rule. And I think because we're still getting used to the e to this, it's going to be safer if I use quotient rule, just because you'll see what's happening a little bit better. All right, so how do I do quotient rule? Quotient rule says the bottom, which is e to the x plus e to the negative x, times the derivative of the top, which is 0. Okay, so that whole first thing is going to 0 out. Minus the top, so minus 4, times the derivative of the bottom. So take it a step at a time. What is the derivative of e to the? I write what's sitting there, times the derivative of my exponent, and the derivative of x is 1. Okay? And then this one, I write what's sitting there, times the derivative of my exponent, which is negative 1. So this plus is going to turn into a minus. Okay? So I have bottom times the derivative of the top, minus the top times the derivative of the bottom, all over the bottom, e to the negative x squared. So your final answer, that goes away, not the negative, and then this is your answer. You're done. Okay? So I'm going to try and get through a few more of these. All right, so we're integrating. Okay, so integration, I'm going to use substitution. And remember, we're trying to get away from you actually writing it, but you're not going to necessarily see it yet. So what I have is the integral of e to the negative x to the 8th. So my exponent has an exponent, which is just fine. And then that's going to be multiplied times the negative 8 x to the 7th dx. Okay, so I want to know what my u is. As soon as I see e, I am going to immediately try and make the u for substitution be his exponent. Okay, so I'm going to ignore this for a second. I see an e. I'm going to gravitate towards this and make that my u. So in this case, my u is the negative x to the 8th. Well, what's his derivative? His derivative is a negative 8x to the 7th dx, which is exactly what I have. So in reality, this is an e to the u du. And if you remember, based on your little sheet right here, the integral of an e to the u du is itself plus c. So my integral becomes e to the u plus c, but you started in next world, so you better end in next world. So e to the u, what's your u? It's a negative x to the 8th plus c. And then how do you check your work? Well, if I check my work, the derivative of a constant is 0, and the derivative of an e to the means I write what's sitting there times the derivative of my exponent. So I've just undone it, so I did it right. All right, so the next one says I have an e to the 7x minus 9 dx. Again, so you may already be used to it, and you may be fine just saying, hey, I know what I need versus what I don't need. But for these ones, I'm going to go ahead and write out the use substitution. So I see an e, so I'm going to immediately drift towards the fact that my u is the exponent, which makes my du a 7 dx. I've got the dx, I need a 7, so balance with a 1/7. And this is now 1/7 times the integral of e to the u du. So 1/7 e to the u du. That integral is just e to the u plus c. Except for I started in x world. So that means I've got a 1/7 e to the 7x minus 9 plus c. Okay. What else have I got? All right, so this one is kind of exciting. We have e to the, hang on. So I'm doing the integral of e to the square root of 3x over the square root of 3x dx. Okay. And so if I don't know what to do, try something I know how to do. Well, what I've been saying the whole time is if I've got e's, I'm going to start use substitution with my exponent. So my u is going to be the square root of 3x, which again is the same thing as 3x to the 1/2. So if that's the case, what is my du? My du is 1/2, times what's sitting there raised to the negative 1/2 times the derivative of the inside, dx. So what do you have here? This is actually 3/2, and then I've got a 1 over the square root of 3x. That's what this part is. So the 3 and the 1/2 became 3/2. This became 1 over the square root of 3x, which is what I have, because I can multiply anything by 1. So I've got 1 over the square root of 3x dx, which means all I'm missing is 3/2. So if I need a 3/2, I'm going to balance with a 2/3. Okay, so this now becomes 2/3 of the integral of e to the u du, which becomes 2/3 e to the u plus c. So e to the u plus c, and make sure that x stays underneath the radical. Okay, so again, if you take your derivative, your constants will reduce out, and then the derivative of your exponent, this will drop to the bottom with the negative exponent. So you have that one right. All right, we got time for like 1 or 2 more. I've got e to the, so e to the 1 over x squared over x to the 3rd dx. So again, I see an e. So the first place I'm going to try is I'm going to rewrite this as an x to the negative 2. So my u is an x to the negative 2. So x to the negative 2. Which makes my du negative 2 x to the negative 3 dx. Well, what is x to the negative 3? It's the same thing as over x to the 3rd. So this right here is this part of my du. So all I'm missing is a negative 2. So use a negative 2, balance with a negative 2, or a negative 1/2. Okay, so I get a negative 1/2 e to the u du, and the integral of e to the u is e to the u plus c. So negative 1/2 e to the x to the negative 2 plus c. And then that's it. So we'll pick up with the last ones, or with the back half of it on the next section.